So let's start. So today we are going to discuss about Festo CP Factory application module magazine. And the order number is D13007. This is the official manufacturing number. If you want to order this, you have to use this number D13007. And the type code is a CP AMMAG. So CP means cyber physical, AM means this is application module, and MAG means magazine module. Series means CP systems. That means this is one of the module associated with the cyber physical systems of Festo, and the category is application module. Application module means the job is to do a particular application. So this was developed to do a particular application. That is what is called a application module. So what is the main job of this magazine? Okay, so the main job of this magazine is to feed carrier so we have carrier, right? Okay, so feed workpiece front cover or back cover to the carrier. This is what is the job of magazine. So once the carrier will reach us here, this magazine will give either front cover or back cover feed either front cover or back cover into this carrier. This is what is the job of this application module. Okay, let's see how this is working. Okay, so we have conveyor belt, right? Okay, so the conveyor, we have a conveyor. So the conveyor is coming, sorry, not conveyor, the carrier is coming through the conveyor, right? Okay, and it will reach us here into the magazine module. So carrier, as you already know what is a carrier, right? So carrier is a small platform where we can place the front cover and back cover, right? Okay, so now the carrier is coming. Now the carrier is coming here, right? Okay, so now the carrier is coming here, right? Okay, once it will reach us here, as you already know, we have light barrier, right? So the light barrier sensor will detect it, right? So light barrier we have discussed in the last class. This is using infrared light. Okay, this is a sensor, right? So there is a light, right? Okay, if the carrier is coming, it will make an obstruction here, right? So this will break the light. Okay, if carrier is coming and it will break the light, so the system will detect that what carrier reached, right? Okay, so PLC will get an information that okay, carrier reaches here. Okay, once the carrier reaches here, then the conveyor will stop the carrier here. Then after this, okay, now the carrier is here. Okay, so then the carrier will check different situations, right? Okay, first one is empty. Okay, for example, now the carrier is empty. That means there is no workpiece. right? There is no workpiece on the carrier. These are the three scenarios here, right? And the second condition is there is a front cover on the carrier. Okay, so sensor will detect the front cover. And we have the third situation, that is there is a back cover on the carrier. So based on this, so now the sensor detected, okay, either empty or there is a front cover or there is a back cover on the carrier. So based on this information, now sensor will detect it, any one of these situation, right? Then after this, this message will be communicated to the where? Communicated to the PLC, right? Okay. So PLC will check, okay, for the next process whether front cover is required or back cover is required or no cover, right? So PLC will check. So the sensor will send this information to the PLC, and based on this, the PLC will check, and based on that, it will take appropriate decision. Okay, so now the PLC will give an instruction, right? So what will happen? So if the PLC will give an instruction, now the the cover is here, right? Okay, if the PLC will give an instruction, okay, so cover will be coming out of this magazine into the carrier. Okay, front cover, front cover, front cover, front cover. Okay, so for example, in the magazine we have 4 front covers, right? Okay, so one front cover will be coming out of this magazine, and it will be uh, put on where? On the carrier. Understand? Okay, once the front cover or back cover reaches here on the carrier, okay, then the conveyor will again start. Okay, then the conveyor will move to the next station. So this is the working of this. This is the complete working of this magazine. Okay, so once again, so yeah, once again, this is our carrier. Sorry, this is our conveyor belt. Okay, so this is our conveyor belt. So this is our carrier. So the carrier is coming. Okay, so once the carrier reaches here, we have a light barrier sensor. So light barrier will identify, will locate this this carrier, right? Okay, then carrier will stop. Then after that, sensor will check, okay, front cover is available or back cover is available or nothing. So the sensor will check these 3 different scenarios, and this information will send to the PLC, right? Then PLC will take their decision, and based on this instruction from the PLC, suppose the magazine will give the necessary part into the carrier. Okay, after that, carrier will release, and the carrier will move to the next station. This is what is the working of magazine. Okay. Okay, so coming to the technical specifications, starting with the electrical connection. So electrical connection is 24 pin IEEE 488 female cis link. So we will be using 24 pin syslink connector to connect to the PLC. So we can connect this module to the PLC using 24 pin uh, syslink connector. That means having 24 pins, right? And this is a female connector and having syslink cable, right? So through this sensor signals, output signals, power signals, everything will be traveled to the PLC. So during the maintenance check, we have to check whether the connector is loose or not. Then what about the cable? Is it damaged or not? Then what about the pins, etc. Then coming to the pneumatic connection. So pneumatic connection, we have a tube with 4 mm outer diameter. Okay, so this is like a tube and the outer diameter was 4 mm. 4 mm outer diameter. This is the tube size, right? So using this air tube, compressed air from the cylinder to the magazine, compressed air will reach us to the module through this tube, and after that magazine will work. So during the maintenance, we have to check whether the tube is having any leakage or not. Any cutting was happening in the tube. And again, we have to check whether the connector is loose or not. Then the third one will be the operating voltage. Third one is the operating voltage. So operating voltage is 24 VDC. So 24 VDC mean volt DC power supply. So this will be using to operate the sensors, solenoid valves, PLC signals, etc. So using the multimeter during the maintenance, using the multimeter, check whether the voltage is 24 VDC or not, because the operating voltage required is 24 VDC. Then coming to the operating pressure, 6 bar. So we need 6 bar pressure required. That means compressed air pressure. If the pressure is less than 6 bar, cylinder will not move properly. If the pressure is more than 6 bar, sometimes components will be facing some damage. So during the maintenance check the pressure regulator, that the pressure regulator is showing 6 bar or not. So to operate this system, we need 6 bar pressure. Then IO. IO means input, output. Okay. So input 7, this is 7 DI and output 5 DO. This is very important specification. Okay, so 7 DI means 7. This is having 7 digital input and 5 digital output. So this means this will be the signals to the PLC, right? So for example, light barrier, carrier sensor, front cover, back cover, cylinder, end sensor, magazine position sensor, home sensor, etc. So there will be 7 inputs. Okay, then 5 digital outputs. So we have PLC, right? Okay, so PLC can send how many outputs? 5 outputs, right? So PLC can receive 7 inputs, and the PLC can produce 5 outputs. Okay, so 5 DO. This 5 DO means PLC can send 5 commands from the PLC to the application module. Okay. So that means, for example, conveyor start, conveyor stop, cylinder extend, cylinder retract, indicator lamp, etc. So these are some examples. So simply we can say this input to output. So simply we can say we have sensors, right? Okay. So from the sensors, PLC can receive how many inputs? 7 inputs, right? So from the PLC to output, how many outputs PLC can produce? 5 outputs. So that is what is called a 7 DI and a 5 DO. DI means digital input, DO means digital output. Okay, then coming to the magazine. Okay, stacking magazine. And the capacity of this magazine is 10. So this means we can store 10 workpieces at a time. Okay, so for example, we can store 10 front cover at a time. Once the carrier will reach us here, okay, only one cover will go down. Okay. After that, we have to fill the magazine. Then coming to the dimension. So coming to the dimension of this magazine, let's see. So this is our magazine, right? Okay. So the total height of this magazine, what is the total height of this magazine? It is approximately how much? Let's see. 525, right? So it is 525. This is the height. Okay. And this width is how much? 340. So this width is 340. And this depth is how much? 185. So this is the dimension of this magazine. So during the maintenance time, we have to check whether this system is receiving 24 voltage or not. Okay. And another one is syslink. Syslink connector is properly connected or not. Then the input output, check whether the input output LEDs is working or not. And also check whether the check whether the system is receiving 6 bar pressure, air pressure. Check whether the system is receiving 6 bar pressure or not, or any leakages, air leakages. And also we have to check the tube. Okay, so as I have mentioned, we have a 4 mm tube, right? 4 mm outer diameter tube. Okay, whether the connection of this 4 mm tube is properly or not. So we have to check. So during the maintenance, we have to check the electrical, pneumatic. Then coming to the mechanical side of this magazine. Okay, so we have to check whether the workpiece cover is properly arranged in this magazine. Okay, and also we have to check whether the cylinder is working very smoothly or not. And also, once the carrier reaches here, whether the carrier is properly placing here. We have to check. Then coming to the sensors, okay, check whether the light barrier is working properly or not. Okay, then check whether the front cover sensor is working or not, back cover sensor, home sensor is whether the home sensor is properly detecting the workpiece or not. Then coming to the PLC, okay, as I have mentioned, we have how many, then as I have mentioned in the PLC will receive 7 inputs and the PLC can produce 5 outputs, right? Okay, so check whether the PLC is receiving 7 digital inputs, okay, plus the 5 outputs. Okay, check this whether the PLC is receiving 7 inputs or and 5 outputs. Make sure that no fault or error. Okay, so next we will discuss more about the inputs and the outputs. Okay. Okay, so we have our PLC, right? So this PLC will receive how many inputs? 7 inputs, right? So here we have mentioned DI, right? DI and DO, right? DI means digital input, DO means digital output. Okay. So what do you mean by this digital input? Okay, what do you mean by digital input? So digital input means we have sensor, right? Okay, so from sensor to PLC, this signal is what is called a digital input signal. Sensor to PLC. The signal that is traveling from sensor to PLC is what is called a digital input. For example, if the sensor will find one situation or one anything, okay, then it will send true. Okay, so for example, if the sensor identified a front cover. Okay, so if the sensor identified a front cover, it will send a true message to the PLC. True means 1. Okay, if there is no front cover, then it will send a false message, 0 to the PLC. Right? So like that, the PLC can receive how many digital inputs? 7 digital inputs. This is what is the meaning of input signals, DI. So DI means the signal traveling from sensor to PLC. That is what is called a digital input. Okay, so let's see. Okay, so 1, 2, 3, 4, 5, 6, 7. How many inputs? 7, right? So 1 is true. Lift cylinder in upper end position. Okay, so for example, so we have the cylinder, right? So the cylinder is in upper end position. Cylinder in upper end position. So the reference will be CLBG1. Okay, so what is the duty of this sensor? So the sensor will check whether the cylinder completely reaches the upper end position. Okay, if the cylinder reaches the upper end position, okay, then that will be displayed as true to the PLC. Okay, if it is false, that means the cylinder till the cylinder not reached the upper end position. So what is the use of this? What is the use of this input? So it is to make sure that before starting the next step, make sure that the cylinder reaches the top. Then next is lift cylinder in lower end position. Here, lower end position, CLBG2. Again, the same, the meaning will be same. Okay, so the only difference is make sure that the cylinder reaches the lower end position. Okay, if the cylinder reaches the lower end position, that will be true. And if it is the cylinder is not reached to the lower end position, it will be false. So during the maintenance check, we have to check the cylinder and also check the sensor, whether the sensor is properly working or not. Then the third input is separator closed. Okay, CLBG3. So the sensor will check whether the separator is completely closed or not. If the separator is closed, it will be true. If the separator is open, like false. So what do you mean by separator? Separator is a mechanism to release workpiece one by one. That mechanism is what is called a separator. Okay, whether the separator closed or open. Then the fourth input will be separator open, CLBG4. Okay, so this will check whether the separator opened or not. So true means separator open, false means separator closed. So PLC will be observing the separator open and closed and control the flow of the workpiece, right? Then next is workpiece present in the magazine. So this sensor, that will be CLBG5. So this will check whether the magazine is having workpiece or not. So this sensor will check whether the workpiece is there in the magazine. Okay, so true means workpiece is present, false means magazine is empty. Then number 6, magazine front cover, magazine back cover. So front cover mode, true, palette present. Okay, so this will be showing that carrier reaches the magazine. Carrier or palette reaches the magazine. Then back cover mode, true, front cover present. So sensor will identify in the carrier front cover is available or not. Based on that, PLC will decide the next step. Then magazine front cover or back cover confirmation. CLBG8. Again, true means front cover already present. Okay, that means CLBG8. So this means the carrier is having front cover. Then back cover mode, back cover already present, true. So this means carrier is having back cover. So PLC will check, will receive all these inputs, and based on that, for example, if the carrier is having a cover, okay, so magazine will not give one more cover. Okay, in this way we can avoid the duplicate feeding. So through this sensor, PLC, now the PLC understands that, okay, so now the carrier is having a cover. Okay, so there is no need to give one more extra cover. In this way, we can avoid the duplicate feeding. Then this address, okay, here this address we can see percentage I. First one is 0.0, second one is I 0.1, then I 0.2, I 0.3, like that. I 0.04, right? I 0.6, right? I 0.7, right? 1, 2, 3, 4, 5, 6, 7, right? So what is the meaning? So I means, as you already know, this is what is called address. Okay, so I means input. Okay, so this 0 represents input byte number, and 0.0, this represents bit number. So PLC will check this address. Okay, so PLC will check this address. Okay, Y 0.0. Okay, and confirms that, okay, cylinder reaches the top and upper end position. Or the PLC will check percentage I 0.1 and make sure that the cylinder reaches the lower end position. So PLC will check this address. Okay, so the complete workflow will be like this. I will show here. Yeah. So the complete workflow will be like this. So we have the conveyor belt. So this is our conveyor belt. So carrier is coming. This is the carrier. So the carrier is coming. Okay. So the carrier reaches here. Okay. So workpiece sensor I 0.4. Then lift cylinder down I 0.1. Then separator open I 0.3. Okay, release the workpiece. Separator closed. Then lift cylinder up That means I 0.0, right? I 0.0. And then front or back cover sense, I 0.6, I 0.7. And PLC will operate the next station. So during the maintenance, we have to check these input values. These input address. During the maintenance, check these input address. Okay, I 0.0, whether the upper lift cylinder sensor is properly working or not. Similarly, I 0.1, lift cylinder lower sensor is working or not. Okay, the separator is closed or open. Okay, whether the separator is completely closed or open. Check workpiece is available on the magazine. Whether the sensor is detecting the pallet or front cover or back cover properly detecting or not. Here we can see two addresses, right? Address CP lab, address CP factory. So CP factory address CP factory means this means we will be using this address in the real CP factory. Okay, when we operate the real CP factory, in that real CP factory system, this is the address using. But for training and for laboratory systems, these are the PLC input addresses using. But the main important point is that the sensor operation is same in both the cases. Okay, the only difference is the input address. So in the CP lab, say for example, this is I 0.0, it will be I 2.0 in the CP factory. That is the only difference, but the sensor working will be same. Okay, then, okay, as we have already discussed, we have in this system, we have how many inputs? Okay, so we have, so we have discussed, we have 7 digital inputs and 5 digital outputs. What do you mean by input and output? So we have PLC, right? So digital input means PLC can receive 7 inputs and PLC can produce 5 outputs. That is the meaning. Input output. This is the meaning of this input output. Okay, coming to our output. Okay, let's see one by one. Okay, so output means, what is the meaning of output, right? First, you should understand what do you mean by output, right? So output means we have the PLC, right? Okay, so PLC, from the PLC, command will be coming and it will go to the actuator. So actuator means cylinder, valve, lock. This is what is called actuator. That means Actuator will produce the real motion. Whatever commands we will be receiving from the PLC, actuator will produce the real motion. For example, cylinder will be moving up or down like that. Okay. So this is what is called output. So once the PLC taken an appropriate decision, okay, so we have to execute that decision, right? Okay, for example, solenoid valve, pneumatic cylinder, lock, etc. Okay, let's see one by one. Okay, so now PLC, right? Okay, so output. One is true, move lift cylinder up. So CLMB1. Again, we have address CP lab, address CP factory. Okay, if this is true, what will happen? Move lift cylinder up. If this is true, what will happen? Lift cylinder will move up. Lift cylinder will move up. If this is false, it will wait. Cylinder will stop and it will wait for another command. Okay. Okay, now the carrier is here. So workpiece delivered, right? So what will be the next step? The next step is to move the cylinder up, right? Okay. So this is one output. Then the second one is move lift cylinder down, CLMB2. If this is true, what will happen? This lift cylinder will go down. True means cylinder down. Then next is close separator. So close separator is used to close the separator. So if it is true, that means separator closed. So separator closed means what? Okay. It will release, separator closed means it will release one workpiece at a time. Okay. If the separator is closed, the next workpiece will not come. Okay. Then next is open separator. This is to open the separator. So if it is true means open separator. Okay. If separator will open, one workpiece will fall into the carrier. Okay, so how this is working, let's see. So suppose we have our magazine, right? Let's see, we have our magazine. Okay, and we have workpieces arranged, right? Okay, so separator closed. So if when the separator open, one workpiece will fall into the carrier. Then open lift cylinder end position lock, CLMB5. Open lift cylinder end position lock means once the lift cylinder reaches a particular position, okay, this will lock. Open lift cylinder end position lock. Otherwise, what if there is no lock? What will happen? Cylinder will move itself, right? So the position will change. Workpiece wrongly will fall. So for precision and accuracy, so this system is using this locking system. Okay, so from the PLC program, command is coming, right? Say for example, Q 0.0 lift up, right? Then Q 0.1, that means lift down. Then Q 0.2 separator close. Then Q 0.3 separator open, and Q 0.4 lock open. So the procedure will be same. Let's again go to our, this one, magazine, right? Okay, so this is our conveyor belt. So carrier is coming here. So carrier reaches here. Okay, sensor will identify the carrier, and then PLC will check whether the carrier is empty or not. If the carrier is empty, then the magazine will feed workpiece into the carrier, right? So lock will open, then cylinder will go down. Cylinder will go down. Cylinder will go down, and separator open. One workpiece will coming out of this magazine. Okay, after that, separator closed, so that one more workpiece is not coming from the magazine into the carrier. Then after that, the lift cylinder will go to the top. Then this carrier will go to the next station. Yeah, then coming to the address, as I have mentioned, we have address CP lab and address CP factory. This is the address when used in CP factory, but for training and laboratory purposes, this is the address using. So the address will be like this: percentage Q 0.0, Q 0.1, Q 0.2, Q 0.3, Q 0.4. So Q means, so this Q represents output, right? So 0 means output byte, and the 0.0 means bit number. So during the maintenance time, we have to check whether this during the execution of this address, whether the system is working or not. Okay. So we have mentioned the inputs and outputs, right? Okay. So input means what? I have mentioned input means from sensor to PLC. Here in this system, this PLC can receive how many inputs? 7 inputs, right? Okay. So the sensor will send the present situation to the PLC, right? Okay. For example, whether the cylinder is on the top, or whether separator is closed, whether workpiece is available or not. So the present situation will be transferred to the PLC using these 7 inputs. Okay. And then output means from PLC to the actuator. Okay. What is actuator? Actuator means this is where our real motion will be happening, right? So from the PLC to the actuator is what is called output. So in this magazine, having how many outputs? 5 outputs, right? Okay. So for example, percentage Q 0 point, say any number. Okay, move cylinder to the top. Separator, open the separator or close the separator. Okay, this will be from this output. So the real movement will be from this output. The present situation will be known by the PLC from this input, right? Okay, so these 5 outputs will be responsible for the movement of the magazine. Okay, so these are the 5 outputs responsible for the movement. Okay. Okay, so let's see one video. So you see the carrier is coming, right? So carrier reaches here, then cylinder down, put the cover, and then the carrier is going to the next station. Okay, so carrier is coming, then cylinder down. Okay, open the separator, put the cover, and then move the carrier to the next Okay, the carrier is coming, cylinder down, open the separator, put the cover, and the carrier is moving to the next station. So this is the working of this, what you call the magazine. So I have already mentioned we have to check the compressed air supply. We need a 6 bar pressure to operate this system. Okay, we have to check the system pressure and how much pressure is required. 6 bar is required, right? 6 bar pressure is required to operate this system. Then this is our power supply. Okay, check the power supply and establish if necessary. Then we have to switch on the main switch at the individual stations and wait for the component startup. This is our main switch, okay, of individual stations. Then unlock the emergency switch. This is our emergency switch. Unlock the emergency stop switch and press this reset button. Repeat the process for all other stations on the production island until the reset lamp goes out. Okay, so turn on all the stations. Then set up the station via the HMI, that means human machine interface, and switch on to automatic mode, auto mode. Okay, repeat the process for all other stations on the production island. So coming to the overall system architecture of this Festo CP Factory CP Lab system. So as you already know what is a CP Factory, right? So CP Factory means this is a smart manufacturing training system based on Industry 4.0, right? This is a smart manufacturing training system based on Industry 4.0. Here we have connected multiple modules, okay? Connected multiple modules and converted into this a production line. In the CP Factory, this is having two different modules. One is the basic module, right? And the second one is the application module. So basic module means this is the basic unit to transfer workpiece or carrier from one location to another. For example, this conveyor, what is the duty of this conveyor? Is to transfer workpiece or carrier from one location to another. This is what is called a basic unit. CP lab conveyor, CP factory linear, CP factory shunt, CP factory bypass. So this basic module, they cannot do assembly process or pressing operations, etc. So their main duty is to transport. Okay, so their main duty is to transport the carrier or transport the workpiece. This is their main duty. Then we have another module is what is called application module. Application module is designed to do one particular application. So for example, let's take this example: magazine module, press module, pick and place module, assembly module, quality inspection module, etc. So this will be directly interacting with the workpiece. If we combine the basic module plus the application module, we will get a station. Okay. So this is a magazine station or pressing station, quality inspection station, like that. So if you combine the basic module plus the application module, you will get the station. If we have conveyor only, it will move carrier from one location to another. Okay. If we have this press module only, just imagine if we have press module only, we don't have carrier. So we need to transport the carrier from one location to this location, right, through this basic module. If we combine these two, then it will becomes a station. What do you mean by station? So station means it is a unit to do one particular operation or one particular manufacturing process. For example, magazine station, press station, assembly station, quality station, etc. You know, in a factory, what do you mean by a production line? So the complete production line will be multiple stations will be connected. Okay. So the multiple stations will be connected so that we will get a complete production line. So for example, we have magazine stations, assembly stations, press, quality checking, storage, etc. So this is what is called a production line. Here, this black object is what is called a carrier. What is the duty of this carrier? The job of this carrier is to transport pallet or workpiece from one station to another through this conveyor belt. On the top of this carrier, we will place this pallet. Okay. So what is the job of this pallet? The job of this pallet is to hold this workpiece properly. Okay. And this carrier plus pallet will reach the correct station. Okay. It is their duty. Okay. To transport this workpiece to the correct station. This is the duty of this carrier plus pallet. Okay. So this is the carrier. Okay. On the top of the carrier, we will place this pallet. Okay. And on the top of this pallet, we will place the workpiece. Okay. So the duty of this pallet is to hold this workpiece properly without any other movement. Understand? Okay. Here, so when we take an industry, industries producing products, right? In our case, our product is like a small mobile phone, right? The sample model of a mobile phone. It is having a front cover, back cover, and inside there is a PCB box. Okay. To understand the concept here in this lab, the product is what is a simplified mobile phone. So here the task is to manufacture a simplified mobile phone. Okay. So what are the three components of this simplified mobile phone? It is having a front cover. Okay. So front cover means, it is having this side walls, right? If you see this side walls, this is what is called a front cover. Okay. And inside this, we will be having the board, printed circuit board, and then we will be having our back cover. Okay. Check what is the difference between front cover and back cover. So front cover means having this wall thickness more, but here the wall thickness is very less. If the wall thickness is more, then we can say this is the front cover. Okay, because this is front. The other one is called a back cover. And inside this board, we have two options. One is we can connect two fuses. Maximum two fuses we can connect. So in the assembly station, the assembly robot will assemble two fuses into this PCB, into this circuit board. Okay. Okay. So the working will be like this. So the working will be like this. From the carrier, this will reaches the magazine station, right? So from the magazine station, this front cover is coming, okay, into the carrier. Then this carrier is moving to the next station, right? Okay, it will reaches to the assembly station. In the assembly station, the robot will assemble this PCB into this front cover. Okay, then plus the back cover, right? Then it will go to where? Go to the pressing station. It will go to the pressing station where uh, this will press, right? Then after that, it will go to the quality station, and final inspection will be completed. And then after that, it will be transferred to the storage. This is the complete manufacturing workflow. So we have our basic module. Okay, as I have already mentioned, the duty of this basic module. Yeah, the duty of this basic module is to transport the carrier. So the application module will do one particular application, right? So if you combine basic module plus application module, it is what is called a station. And on the top of the carrier, placing the pallet, right? So the pallet will hold the workpiece properly. And the complete stations, combine all the complete station is what is called a production line. So during the maintenance time, we have to check whether this conveyor belt is working properly or not, whether the motor is working normally or not, then light barrier sensor is working or not, whether the carrier is properly working or not, then pneumatic cylinder is working or not, whether the pressure is 6 bar or not, sensor is properly detecting or not, whether the solenoid valve is working or not. And also check whether the carrier and pallet is okay or not, whether the pallet is properly locking into the carrier, okay, whether the workpiece is properly placed on the pallet or not. So this is the basic information about the uh, overview of the system. Okay, so next we will see more details about the application module. Okay, so what is the job of this application module? I have already mentioned we have the conveyor belt like this. Okay, so from the conveyor belt, the carrier is coming, it will reach us here, right? So the job of this application module, here we have our front cover. Okay, so transport, give this front cover into this carrier. This is what is the job of this application module. Okay, so properly placing this front cover into this pallet or carrier is what is the job of this application module. As I have mentioned, we have two different types of cover. One is front cover and another one is back cover. I have mentioned front cover means it is having the biggest wall thickness. That is what is called a front cover. The other one is the back cover. Okay, so let's see what are the main parts associated with this, right? So this one. So what is this? This is what is called a valve terminal. This is where the pneumatic solenoid valves there. So as I have mentioned, we have the PLC, right? So we have PLC input and PLC output, right? So the output will come here into the solenoid valve. Okay. So PLC output will reach us here to this solenoid valve. So then the valve on, when the valve on, the compressed air will go to the cylinder and the cylinder will move. So the main job is to move cylinder up or down, separator open, close, etc. During the maintenance, we have to check the air leakage, solenoid LED on or not, valve coil producing more heat or not. Then the second one, this one. This is what is called a magazine slot. So magazine slot is the area where we can we can store our workpieces. For example, front cover. And the capacity of this magazine will be 10. Okay. If the carrier will reach us here. Okay. Only one cover will go to the carrier. So during the maintenance, we have to check the any workpiece jam will be there. Slot is neat or clean or dirty, whether the cover is properly stacked or not. Then number 3 is fiber optic device workpiece available. This one. So the job is to detect whether workpiece is available on the magazine or not. Okay. So true means magazine filled, false means magazine empty. Check the fiber cable, sensor LED, and also check any dust. Then coming to the fourth one, cylinder for workpiece separation. This one. This is what is the cylinder for workpiece separation. This is the main pneumatic cylinder. Okay. So now in the magazine, we have 10 front cover, right? Okay. So this separator will give one front cover to the carrier at a time. So during the maintenance, we have to check any air leakage, stroke is correct or not, whether the rod is bent or not. And number 5, check workpiece at running in. Number 5. So this is what is called an Henry sensor. So Henry sensor will check whether the carrier reaches here or not. Okay, whether the carrier reaches the magazine station or not. So this sensor will detect whether the carrier reaches this station or not. Once the carrier reaches here, Okay, so PLC will stop, then magazine will feed the front cover into the carrier. Check the sensor alignment and whether the carrier is whether this sensor is detecting the carrier or not. Then coming to the sixth one is what is called, I have mentioned in the last session also. Sixth one is called input output module. I have already mentioned we have 7 input and 5 output, right? So 7 input means PLC can receive 7 input, PLC can produce 5 output. That is the meaning. So this is we can say this is the brain, or this is the interface between the station and the PLC. This is the communication interface between the PLC and this application module. Okay, so we have sensors, right? We have sensors, then we have PLCs, we have outputs, right? So all these informations will be passing through this input output module. So during the maintenance, we have to check whether the power is 24 voltage or not. Input output LED on or off, connector is loose or not. Then coming to the number 7, that is the cylinder height adjustment, this one. So this will be helping to move the cylinder up or down, so that this will help to reach the workpiece in a proper height. So during the maintenance, check whether the height is correct or not, and also check the smoothness of the cylinder. Number 8, locking cylinder height adjustment N position. 8, this one. Once the cylinder reaches a particular position, it will lock, right? If there is no locking mechanism, what will happen? The cylinder will move, okay? And the workpiece will go in a wrong position. So to avoid that situation, using the locking mechanism for accurate feeding. So during the maintenance, check the lock release as well as the lock cylinder leakage. Check workpiece at running out. Number 9. Okay, this is another sensor. Okay, so as I have mentioned, we have this conveyor belt. So when the carrier is coming here, the sensor will detect, right? Okay, once the carrier leaves this station, this sensor will detect. Okay, so once the carrier leaves this station, PLC will ready the next station. So during the maintenance, we have to check the working of these 2 sensors. Okay, this is to detect the entry and exit of the carrier, right? So during the maintenance, we have to check whether this sensor is working properly or not. Then this conveyor speed, checking the conveyor speed is correct or not. So the complete working will be like this. So the carrier is coming from here, okay? And once the carrier reaches here, this sensor will activate and the sensor will detect that, okay, so carrier reaches here. Okay, then the PLC will stop this carrier. Then magazine sensor will check workpiece is available or not. Then the lock will release, lift cylinder height adjust, separation cylinder push. Then one workpiece will go to the carrier. Okay, then after that release the carrier. Okay, and move this carrier to the next station, and this sensor will detect, running out sensor detect, then coming to the then go to the next station. So I have already mentioned we have the PLC, right? We have the PLC, and this PLC is communicating with this input output module, right? Okay. So we have sensor. So we have this sensor, right? Okay. For example, so this sensor is communicating with this input output module, right? Then this this message transferred to the PLC, right? Okay. Then this will be communicating to the this one where this valve terminal, right? Okay. Then it will release this cylinder, right? Then feed magazine will feed one cover into the carrier. So finally, we have our valve terminal, right? This will be controlling the valves, pneumatic valves, check the air leakage, solenoid, LED, etc. Then we have our magazine slot number 2. This is to store the workpiece, check jam alignment cleaning. Then we have the fiber optic sensor to detect the workpiece available or not. Dust check dust fiber cable, LED, etc. Then separation cylinder, it will release the workpiece, stroke air leakage, etc. Then we have running in sensor, it will detect the carrier alignment detection. We have to check. Then we have the input output module. This is to communicate with the PLC, right? 24 voltage LED connectors we have to check. Then height adjustment cylinder to adjust the height, lift height, check the smooth movement. Then locking cylinder to lock the cylinder. This is for check the lock or unlock operation. And finally, the running out sensor to detect the exit of the carrier from the station. Check the detection, conveyor synchronization, etc. Okay, coming to the electrics, separator sensors. So what is the job of this separator? Okay, so I have mentioned, so this is our, okay. Yeah, this is our carrier, right? And this is our station. So the carrier is coming, right? So this is the carrier. So carrier will reach us here. Once the carrier reaches here, now front cover will be stacked here, right? Say 10 front covers will be stacked here, right? So the duty of the separator is to release one cover at a time into the carrier. So the separator will release one carrier at a time. So for that, here we will be using two proximity sensors. Okay, 1, 2, using two proximity sensors. This is to check whether the separator reaches the correct location or not. So PLC will use these two proximity sensors whether the separator reaches the correct place or not. So what is the duty of the separator? The duty of the, see, suppose we have 10 front covers right here, right? So the duty of the separator, if there is no separator, what will happen? All the 10 covers will be fall into this carrier, right? But because of this separator, this is a mechanical system that is used to feed one cover at a time into the carrier. That mechanism is what is called a separator. Okay. So whether the separator reaches the correct location or not, the system is using two proximity sensors. Okay, proximity sensor SMT, this one. So what do you mean by proximity? You know what is proximity sensor? What is proximity sensor? Okay, suppose here we have a separator, right? Okay, so this is a non-contact sensor, right? Proximity sensor means this is a non-contact sensor. That means this sensor is not contacting with this separator, right? Two types of sensors, right? Contact sensor as well as non-contact sensor, right? So this proximity sensor is a non-contact sensor. That means there is no contact with sensor with the separator, and to identify the position of this separator, right? There is no contact. In this module, they have used proximity sensor SMT 8M APS 24 volt E 2.5 OE, part number 574335. This is magnetic read proximity sensor. So this is detecting the magnet in the piston, in the cylinder. Okay, so this is working, and the working is basically like this. There is a magnet in the piston cylinder. Okay, so by detecting that magnet, this system is working. Okay, so we have position 1, right? Okay, so we have position 1, right? What is the name? Proximity sensor. Reference is BG3, right? And the job is lower pole is extended. So lower pole is extended means the separator is having a lower pole. Okay, whether that lower pole is coming outside or not. So this sensor is checking. If this is true, that means lower pole is outside. That means the separator is in the lower stage. That means this can hold the workpiece. If this is false, lower pole retracted. That means the position of the separator changed. Then coming to the next position, number 2. Proximity sensor reference is BG4. So the job is upper pole is extended. That means upper pole is coming out or not. So if it is true, that means upper pole is outside. So the separator can release workpiece in another position. If it is false, then upper pole retracted. So what do you mean by this pole? Pole means a small mechanical lock or a stopper is what is called a pole. This will be uh, using uh, to control the unwanted movement of the workpiece. Why we have two poles? If we use one pole, all the cover will go down. Okay, if you use two poles, only one cover will be coming out of this magazine. So next is this is showing the lifting. So previously, so these are the two sensors associated with the separator. Next is these are the sensors associated with the lifting cylinder. So lifting cylinder, we have discussed up or down, right? So lifting cylinder up or down. Okay, this sensor is used to locate the position of the cylinder. That means the end position, the top end position and the bottom end position. These are the two magnetic proximity sensors. So this is what is called a height adjustment cylinder, right? So the main duty is to reach the workpiece in a proper height, right? And also release the cover from the workpiece to the carrier properly. So in order to inform to the PLC that the cylinder reaches the correct position, either top or bottom end position, we need two proximity sensors, two magnetic proximity sensors. Whether the cylinder reaches top or bottom, we need two proximity sensors. So this proximity sensor will communicate to the PLC that this cylinder reaches the top or bottom using two magnetic proximity sensors. So the lifter cylinder is moving up or down, right? Okay, and adjusting the location of the carrier. Okay, so we have position 1 and position 2, right? So the sensor is sensor SMT10M PS24V E2.5 LOE. Part number 551373. Reference is BG1. So the job is lifting cylinder upper position, right? Okay, if the cylinder reaches the upper position, this will be activated. BG1 will be activated, right? It will becomes true. Okay, if the cylinder reaches the top, this will becomes true. PLC will start the next step. If this is false, that means the PLC knows that okay, the cylinder not reached the top position, right? PLC will wait till the cylinder will reaches the top. Then position 2, that means lifting cylinder lower position. This is the lower position, right? So the sensor is SMD10M PS24 volt E2.5 LOE. Part number 551373 of BG2. So the job is lifting cylinder lower position. This is to check whether the cylinder reaches the top position or not. If the cylinder reaches the top, BG2 will be activated. BG2 true means PLC knows that okay, the cylinder reaches the top. Okay. So if the cylinder bottom, right, so that magazine can start the feed. Okay, if this is false, that means cylinder not reached to the lower position, PLC will not start the next operation. Okay, so these are proximity sensors. As I have mentioned, proximity sensors are, so the cylinder is moving up or down, right? So once the cylinder reaches here, we have proximity sensors, right? But there is no contact. Okay, how this sensor will understand, okay, this reaches the top or this reaches the lower position, upper position or lower position. This is a non-contact sensor, right? Proximity sensor means non-contact. There is no direct contact between the sensor and the object, right? Then how the sensor is detecting that, okay, this reaches the top or this reaches the bottom? Okay, there is a magnet. Okay, actually there is a magnet inside the piston. Okay, so by locating that magnet, this sensor is working. Okay, so there inside the cylinder, inside the piston, there is a magnet. Okay, so by detecting that magnet, this sensor will understand that okay, this cylinder reaches the upper position or the lower position. Okay, so once the cylinder reaches the upper position, what will happen? BG1 is equal to true, right? BG2 is equal to false, right? Similarly, if the piston reaches the bottom lower position, BG1 is equal to false and BG2 is equal to true, right? So the PLC logic will be like this. BG1 true. If BG1 true, move lift up. Yes, next step, right? PLC will check, move lift down. BG2 true. Yes, release workpiece. So the complete working will be like this. Okay. This is our conveyor belt, right? This is our conveyor belt and this is the carrier, right? Okay. So this is our station, right? So the carrier will reach us here. And once the carrier reaches here, the running in sensor will detect the carrier. Then PLC will release the lock, right? Then the cylinder will go down. Okay. Once the cylinder will go down, BG2 will be activated, right? Okay. So once the BG2 is activated, then PLC knows that, okay, cylinder reaches the bottom, right? Then separator will open, okay, and the cover will fall into the carrier, right? Only one cover, right? And after that, the cylinder will go to the upper position. Once the cylinder reaches the upper position, BG1 will becomes true, right? Okay, PLC knows that, okay, the cylinder reaches the top, right? And carrier will release, right? Okay, and the carrier will go to the next station. So next we are going to discuss about light guide. This is a fiber optic sensor system. This is used to identify workpiece. We need to identify workpiece, right? Then similarly pallet, right? Then front cover, etc. So this fiber optic sensor is used to identify workpiece, pallet, front cover, etc. This is one of the major important sensor used in this magazine module, because this is used to identify the this workpiece, pallet, or front cover. First of all, we will start with light guide. So light guide is a fiber optic sensor. Okay, this is an optical sensor. So here we have a fiber optic. This is a fiber optic cable. Fiber optic cable. Okay, so using the fiber optic cable, here we will send a light beam. Light beam. Okay, so light beam is sending, right? And then the retracting, using the retracting light beam, okay, we will use the retracting light beam to check whether there will be an object available or not. This is what is called a light guide. This is what is called a light guide. So once again, here we have a fiber optic cable. Okay, using the fiber optic cable, we will send a light beam, and using the returning light beam, we have to identify whether there is a workpiece available or not. This is what is called a light guide. This is a fiber optic sensor. This is an optical sensor. So here we have a fiber optic amplifier. Fiber optic amplifier, then light beam. Okay, so if the light beam will detect a workpiece, right? Okay, then light will be returning back. PLC will get a signal. Based on this signal, PLC will understand that, okay, workpiece is on the station. Okay, let's see this picture, right? Here we have mainly 6 sections, right? This is what is this section 1, 2, 3. This is what is called a fiber optic amplifier unit. Okay, and we have 4, 5, 6. 4, 5, then 6. This is the fiber optic cable. This 4, 5, 6 is the fiber optic cable, light guide cable. So from the amplifier, uh, light is coming right through this cable to the sensor point. Let's see one by one. We have light guide unit, SOEG LQ30 PAS2L, and reference is BG5. The duty of this is to check whether the magazine is empty or not. Okay, to check whether the magazine is having workpiece or not. So if BG5 is equal to true, that means the magazine is having workpiece. If BG5 is false, that means magazine is empty. So PLC will inform the operator to feed uh, the magazine. Then number 2, light guide unit BG7. Pellet. Okay, so the job is to check whether the carrier or pellet reached or not. If it is true, that means carrier reaches the magazine station. Okay, once the carrier reaches the magazine station, it will stop the it will stop the conveyor. False means till now carrier is not reached and no feed will be happened. No feed will be happening. Then number 3, light guide unit, this one, BG8. This is to check the front cover. Okay, this is to detect front cover is available or not. If BG8 is equal to true, that means front cover is there. No need to add front cover again. False means no front cover. Then magazine will feed the front cover. Then number 4, fiber optic cable, SOOC TBM42R25. This is the light guide table of BG5. Okay, so through this cable, light will go. And number 5, reference is BG7. This is to detect the carrier. This is the cable to detect the carrier. And finally, 6BG8, detect the front cover. Okay, how this fiber optic sensor is working? Okay, so from the light source through the fiber cable, light beam will be coming, right? Okay, and if there is a workpiece here, then we will get a reflection or reflected beam. Okay, and it will be, and that reflected beam will be shared to the PLC. In this way, the fiber optic sensor is working. Here we have different sensors, right? BG5, BG7 and BG8. BG5, BG7 and BG8. So BG5 means magazine empty. BG7 is related to the pellet, that means carrier, and BG8 is related to the front cover. So these are the 3 sensors. So the PLC logic will be like this. What will be the PLC logic? So the carrier is coming, right? So the carrier is coming. Okay, so then BG7 on. So carrier will stop here. Then BG5 will check whether the magazine is filled or empty. Okay, then BG8 will check whether the front cover is available or not. Okay, if there is no, then feed front cover. Feed front cover means cylinder will move, separator open, cover will release. Then the carrier will, after that, carrier will go to the next station. Okay, so next is the input. Next is the input output module XD1, part number 027412. This is the electrical interface module. Okay, so we have sensors, right? We have sensors, actuators, PLCs, right? Right? All the communication will be happening uh, through this input output module. Okay, so this input output module XD1 means this is the electrical control hub of magazine module. Okay, so this will receive signals from the sensor. That means input. Okay, and from the PLC, this will receive output. So this will receive output commands from the PLC and it will send to the actuator. So this XD1 is connected to the frame, right? To the frame of this magazine station, right? So all the sensors, right? All the sensors connected to this, I have mentioned all the sensors connected to this, like, lift cylinder sensors, separator sensors, fiber optic sensors, right? Then actuators such as solenoid valves, then PLC syslink cable, 24 VDC power supply. Okay, so everything is connected to this input output module. Okay, we have different sensors, right? Lift cylinders, we have lift cylinder sensors, we have separator sensors, we have fiber optic sensors. So all the sensors, actuators, everything will be connected to this input output module. So from the sensor, we will get information. So this input output module will receive information from the sensor, right? Then transfer this information to the PLC. Okay. Then based on this information, PLC will give a command. Okay. And say for example, cylinder up. So PLC will give a command called cylinder up. So that command will be go through this input output module to the actuator. So once again, from the sensor to the input output module, then to the PLC, then based on the PLC program decision, again go to the input output module, then go to the solenoid valve, then it will work the pneumatic cylinder or separator. So here we have different LEDs, right? Power LED. So power LED means this will be receiving 24 VDC. If it is off means there is no power. If we use, we have mentioned we have 7 inputs and 5 outputs, right? 7 inputs and 5 outputs, right? Right. So whenever we will use the input or output, okay, whenever this input or output is using, the LED will be blinking here. So for example, BG1 on, input LED on, MB1 output LED on. So this is very much useful for troubleshooting. So during the maintenance, we have to check whether this is receiving 24 VDC using multimeter. Check the connector, syslink, then LED, check the LED status, check the wiring, check the PLC communication, cleaning. So next is this one is showing the pneumatics valve terminal, CPVS-C1. This is the pneumatic control unit of the magazine module. So as I have mentioned, from the PLC, right? From the PLC output, we will be getting signals, right? Output signals, right? By adjusting this valve terminal, distributing the compressed air to the different pneumatic cylinders using this this pneumatic control unit. Okay, first of all, what is called a valve terminal? What do you mean by valve terminal? CPVS-C1, valve terminal. So valve terminal means this is a unit. Valve terminal means this is a unit having more number of solenoid valves. Okay, so the job of this valve terminal is to receive signal from PLC. Okay, whatever signal receiving from the PLC, based on that signal, either open or close this this air valve. That is the duty of this valve terminal. And the required compressed air to the required cylinder. This is the duty of this valve terminal. Okay, so basically, simply we can say this valve terminal is a pneumatic traffic controller. That means this terminal will receive electrical signal from the PLC, right? And based on that signal, this will operate. This will either open or close this valve, air valve. Okay, as I have already mentioned, to operate this system, we need how much? 6 bar pressure. We need 6 bar pressure is required to operate this system, right? How pneumatic system is working, right? So we need 6 bar pressure, right? So 6 bar compressed air is coming, right? We need air filter or regulator, then go to the valve terminal, right? So from this valve terminal, this will go to the pneumatic cylinder. So after that, we will get the mechanical movement. So from this valve terminal, the next stage will be the pneumatic cylinder, and then here we will get the mechanical movement. Here in this image, you can see how many solenoid valves in this valve terminal. Total 5, right? So 1, 2, 3, 4, 5. Okay, so every valve there is a special job. Okay, let's see valve 1. This is valve 1, then 2, 3, 4, 5. 3 valves. So valve 1, right? MB1. What is the job? The job is to lifting cylinder up. Okay, so PLC, if PLC is saying MB1 on, if PLC is saying MB1 on, right, then this valve will open. This valve will open. Okay, and the compressed air will go to the bottom portion of the cylinder. And if the compressed air go to the bottom portion of the cylinder, what will happen? The cylinder will go up, right? The cylinder will go up. Then coming to the valve number 2, that is MB2. What is the duty? Down. Lifting cylinder down, right? If MB2 on, if PLC is sending a command, MB2 on, then what will happen? MB2 on means the air will go to the top part of the cylinder. If the air will go to the top part of the cylinder, then the cylinder will go to the lower position, right? Down. Cylinder will go down, right? Then MB3. Next is MB3, close separator. Okay, if PLC is saying MB3 on, then separator will close. It will stop another movement of the cover, right? down. Then valve number 4, open separator. So separator will open. What will happen? Only one cover will go to the carrier. Then valve number 5, MB5, that means MB5, open cylinder clamp unit. Okay, if the cylinder clamp lock will open so that the cylinder can move. So the working will be very simple, right? So as I have mentioned, this is our conveyor belt, right? So the carrier is coming to the station. So carrier will reaches the station, then sensor will detect it, then PLC will take the decision, right? Then for example, MB5 on, right? MB5 on means open the clamp unit, right? Then the cylinder will go down. Okay, open the clamp unit, then MB2 on. MB2 on means cylinder will go down, right? Then MB4 on, open the separator, right? When the separator open, only one cover will go to the carrier. Then after that, MB3 on, separator will close, right? Then MB1 on, right? So MB1 on means the cylinder will, lift cylinder will go to the top. Then after that, carrier will go to the next station. Okay, so from the PLC, right? Okay, from the PLC, output is coming, right? So this output is coming, the solenoid valve will operate. Okay, so valve will open. Okay, so compressed air is going. So compressed air is going, for example, go to the bottom side, then cylinder will go up. If the air is going to the up, then the cylinder will go down, etc. like that. So that we will get the mechanical motion. Okay, so many times we have discussed about separator assembly, right? So this is what is the separator assembly, right? So what is the job of this separator, right? Okay, so we have 10 workpieces, right, on the magazine, right? So at a time we have to feed one cover, right? Okay, so the job of this separator is to give one cover at a time to the carrier. That is the job of this separator. This is one of the main mechanical. Otherwise, what will happen? All the cover will fall into the top of the carrier, right? So this separator will give one carrier at a time. So we have the workpieces stacked, right, on the magazine, right? Say for example 10 workpieces, right, we have stacked, right? So the separator, we will use the separator to give one workpiece to the carrier only. Otherwise, if there is no separator, what will happen? Sometimes 2-3 carrier will fall onto the top of this carrier, right? So sometimes a carrier will jam, right? Assembly will becomes wrong. Sometimes production line will stop. So this separator is a main important part of this light production line. So we will see the separator. So this is what is the separator HPV 1010A. And the part number is 550908. This is the main pneumatic separator cylinder. So the main job is to give only one cover, and by adjusting this separator poles forward or backward, to control the flow of the workpiece. Then number 2, this one-way flow control valve, part number 175041. So one-way flow control valve means it will control the speed in one direction by adjusting the airflow, by either increasing or decreasing the airflow. Okay, adjusting the cylinder. If we increase the airflow, right, cylinder will move very quickly, right? But if you adjust the airflow to a reduced airflow, cylinder will move very slowly. The number 3, one-way flow control valve. Another one, same. This is again same mode. This is for the return stroke. Okay. So compressed air is coming, right? We have our flow control valve. Then go to the cylinder, we will get the mechanical movement. By changing this valve, okay, by rotating this valve, we can adjust the airflow. Okay, if you adjust this clockwise, clockwise means close, right? Clockwise means close, means airflow will reduce, the cylinder movement will slow. If you rotate this in counterclockwise means open, right? Then the airflow will increase. Airflow will increase means cylinder will move very fastly. Okay, so how this separator is working? We have our magazine, right? So we have our magazine, and say we have 10 work pieces, right? Okay, so the separator will hold the workpiece. Okay, once the carrier will reach us here, now the carrier is here. Okay, then BG7 sensor on, PLC will be ready, MB4 output on, then the separator will open. Okay, once the separator will open, only one cover will go down into the carrier. Okay, then MB3 output on, then separator will close, it will hold the next cover, then carrier will go to the next station. Okay, so next is the another important part of this was lifting cylinder with a clamp. Mini slider DGSL10. So what is the job of this unit? So the main job of this unit is to place the carrier or the workpiece in a proper height or proper place and lock it. We have 4 different parts, right? Main one is one-way flow control valve, right? This one. Okay, this is to adjust the flow, right? Then we have another one again. This is also one-way flow control valve to control the flow. Then number 3 is end of stroke locking. And number 4 is mini slide DGSL10. Then one-way flow control valve, first one, GRLA M5 QS3 LFC. So this one-way flow control valve will extend, will control the mini slide movement. Okay. Compressed air is not directly go to the cylinder. First, it will go to the flow control valve, and by adjusting this flow control valve, the cylinder will move very either quickly or very slowly. Okay, if the airflow is very high, then the cylinder will move very fastly, right? If the airflow is very slow, then the cylinder will move very slowly. Another second one also, one-way flow control valve, the same model. This is to control the cylinder retraction. Okay, and why in this system is having two control valves, two flow control valves. So one port is for extend and another one is for retract, so that we can separately control the two different forward motion as well as the retraction motion. We can adjust. Okay, we can adjust the speed in both directions. We can using this, if using two different valves, right? One for forward motion and another one is for retraction motion, we can control the speed, right? Then end of stroke locking integrated at a mini slide. Once the cylinder reaches to the last position, this will automatically lock. This is what is called a mechanical end position lock. Okay, once the cylinder reaches the final position, okay, uh, its position should be there, right? Okay, if the position is changing, do not change the position, right? And if there is no locking mechanism, what will happen? If there is no locking mechanism, the position will change, right? Or some vibration will happen, or workpiece will shift. So that's why we will be using this locking mechanism. So for example, if the cylinder reaches to the up position, right, then locking mechanism will be there. That means there will be no movement. Then mini slide DGSI. This is the main pneumatic slide. So this will be used to position up or down. So I hope you understand the step mentioned in this. So once again, this is our conveyor belt. So the carrier is coming, right? So BG7 will detect PLC ready. Then MB5 on, then lock will release, mini slide will go down, separator open. Once the separator open, the front cover will release. And after that, MB1 on, mini slide will go on the top. Once the cylinder reaches the top, automatic locking system will be activated, and then carrier will release from the current station, and the carrier will go to the next station. So this is the complete workflow. Okay, and the pneumatic flow will be like from the compressed cylinder, the compressed air is coming, it will go to the valve terminal. We have flow control valves, right? By adjusting this flow control valve, mini slide will be moving, right? Okay, because of that, the position will be locking. We can lock the position of the cylinder, right? Okay, so now we are discussing about what? Magazine, right? Magazine. Okay, what is the job of this magazine? Okay, so the job of this magazine is to, this is our carrier, right? Once the carrier reaches here in the magazine, the duty of the magazine is to give front cover or back cover to the carrier. This is the job of this magazine. This is completely automatic with the help of PLC, sensors, and pneumatic cylinders, right? So this is completely working with the help of sensors, PLCs, and pneumatic cylinders, right? So this is our conveyor belt, right? So the carrier is coming. The carrier reaches here the station, right? So once the carrier reaches here in the station, we have our light barrier sensor. So the light barrier sensor will detect the carrier, right? Once the light barrier sensor detect this carrier, it will send a message to the PLC, right? Okay. So the PLC will give a command. PLC give a stop command. Okay. Then what will happen? Conveyor will stop, right? Or stopper will be activated, right? Then after that, sensor will check the carrier. Okay. There are three options. There is no workpiece on the carrier. That means carrier is empty, right? And the second one is there is a front cover on the carrier. And the third one will be there is a back cover on the carrier. There are three different cases, right? So based on this, sensor information will send to the PLC, right? Okay. So for example, if the case is first one, there is no workpiece on the carrier, then the PLC will take two decisions: either give front cover or back cover to the carrier. Then if the case is there is a front cover on the carrier, that means no need to give front cover. So this was the message from the PLC. Or if there is a back cover on the carrier, no, the message will be no need to give back cover again. Okay, so PLC will give the necessary outputs, right? Okay, if for example, if there is no workpiece, right, then separator will open. Once the separator will open, it will give one workpiece to the carrier, right? And after that, carrier will release, right? So carrier will release and conveyor belt is moving, right? And the PLC will start the conveyor and this carrier will go to the next station. Okay, so that is the function we discussed. Next is variants. So this application module can handle two different types of workpieces, two variants of workpieces. And the color of the workpieces is irrelevant. Okay, but this application module will be able to handle two variants of workpieces irrespective of their color. Okay, so we have a front cover and a back cover, right? As I have mentioned, front cover means having the wall thickness is more, right? In this way, you can easily identify which one is front cover and which one is back cover. So front cover, so this is the front cover and here the wall thickness is very less, right? So this is the back cover. So this application module can handle two variants of workpieces, front cover. Okay, so this will be representing the front part of your mobile phone. Okay, in this having screw holes, PCB supports, alignment features, etc. Then this is what is called the back cover. This will be representing the back side cover of the mobile phone. Okay, when you compare the front cover and back cover, so the back cover is less complicated than the front cover. When you compare these two, front cover is more complicated than the back cover. In this way also you can identify which one is front cover or which one is back cover. And a very important point is that the color of the workpieces is irrelevant. You can use gray color, black, blue. Okay, nothing will happen. Okay, PLC will not check the color. So PLC will check the shape, position, and program. PLC is not checking the color. You can use gray color, black, blue, that doesn't matter. Okay, how you will differentiate these two different covers, front cover and back cover. Okay, if you see the front cover, you can see it is having more features, right? But in uh, back cover, it is having a simplified shape, right? In this front cover, it is having so many parts so that the PCB we can connect onto the front cover, right? This is like a simply a cover only. So the magazine is using the front version, and magazine is using the back version. So based on the variant, we have to adjust the module, right? Okay, so coming to the process description, right? So the process description is divided into three sections. One is start conditions. Start conditions, start position, and sequence. So before starting the system, all connections have been made properly. Okay, before starting the machine, make sure that all the connections are correct. Okay, you have to check. We have already discussed 24 VDC power connection is required. Then check the PLC communication. Then we need a 6 bar pressure. So check the pneumatic air connection. Then sensor connection. Then valve terminal connection. Then emergency stop, right? Then check workpiece is available on the magazine. So all connections have been made properly. These are the start conditions, right? Then after that, start position. There are two main conditions. First one is lifting cylinder upper position. Okay, so this is the first condition. Before starting the system, the lifting cylinder should be in the upper position. The cylinder of the lifting unit must be in its upper position. Okay, so this will be checking using which sensor? BG1 sensor, right? So if the cylinder is on the top, then BG1 will be activated. BG1 will be true. So this is the first condition. Because why this is required? Because when we start the cycle, if this is in the bottom side, workpiece will go to a wrong location. So this is the first condition. So remember, when you start the system, the cylinder should be in the top position. Then number two, the separating cylinder must be in the rear end position. This, so we have the cylinder, right? We have the main cylinder, right? Okay. So the main cylinder should be on the top, right? And the separating cylinder or the separating cylinder must be in the rear end position. Rear end. That means in the home position. Okay, so So remember these 2 points, very important. First one is the lift cylinder will be in the upper position. Upper position means BG1, BG1 true. And separator cylinder here, rear or home position. Then we will see the sequence. This is the complete operation of the magazine module. Okay, so let's say this is our conveyor belt, right? So the carrier is coming. If a carrier is transported with a workpiece through the light barrier of the application module magazine, the carrier is stopped and an automatic mode is started. Okay, once the carrier will reach us here, light barrier sensor will identify the the carrier. Okay, then carrier will stop here and it will immediately start the automatic mode. Then the second step will be the sensors are checking the condition of the carrier. Okay, there are 3 cases: whether the carrier is empty, okay, front cover available or back cover available. For that, using BG5, BG7 and BG8 sensors using. Okay, then after that, if the conditions are fitting to the requirements, the lifting cylinder moves downwards. Then the cylinder will move down. Okay, once the PLC will take the decision, MB2 on, the lift cylinder will go down, BG2 on, right? Okay, then release the workpiece. Okay, release the workpiece and put the workpiece onto the carrier. Separator will open. So the separator will open. It will release one workpiece to the carrier. Then after that, what will happen? The lifting cylinder moves upward to its start position. Then it will reach us here, MB1 on. Cylinder will go to the top, BG1 on, start position. Then after that, release the carrier and it will leave the application module. Once the cylinder will reaches on the top, conveyor will start. This is the complete working flow. So next I'm going to discuss about how we can operate this module. How we can operate this module and where we can control this, etc. So one of the main important point is that an application module has no control elements. That means in the magazine module, they don't have any start button, stop button, or reset button, auto manual switch. Nothing was there. So this is a self-operating module. We can control this from the basic module or from the CP factory system. For example, we can control this from the CP lab conveyor or CP factory linear module, PLC, HMI, MES, Robotino, etc. And another one is that operation is only possible when it is mounted on a basic module. Okay, we have the basic module. On the top of the basic module, this application module will be there, right? Okay, if there is no basic module, we cannot operate this system. Okay, that means there will be a CP lab conveyor, CP factory linear, CP factory shunt, or CP factory bypass. So as per the manual, they are saying that customers, they can use their own program. The operation can be realized by every customer according to his wishes. The operation of the application module can be realized by every customer according to his wishes. That means Festo is giving only one example PLC program. So if required, you can develop your own Siemens PLC program and you can use it. The supplied programs are only an operating suggestion. So the program given in this manual is only an example program. Okay, you can add new sequence, you can add new logic, you can add new sensors. External controls are also possible. Okay, so not only from PLC, we can control this from HMI, MES, SCADA, etc. General operation is described in the manuals of the CP lab or CP factory system. So this manual is only explaining the magazine module only. But for other details will be available in the CP factory manual. So in this manual, only the operation related to the magazine. So setting the application module magazine at HMI. That means how we can control this system using HMI. HMI means human machine interface. First of all, what is called first of all, what is HMI? First of all, we should understand what is this HMI. HMI means human machine interface. So human machine interface, this is what is called HMI. HMI is the interface between the operator and so I am the operator, right, and the PLC. So HMI is the human machine interface, is an interface between the operator and the PLC. Using this interface, we can start the machine, we can stop the machine, we can change the parameters, and we can see some fault or errors. We can check what is the status of the sensor. We can operate the module in magazine module front or back cover mode. So as per the manual, they are saying that the application module should be in setup mode. Setup mode. So before changing the parameter, we should change the mode to the setup mode. So we have two modes, right? So one is front cover mode, right? One is front cover mode and another one is back cover mode. One is front cover mode and another one is back cover mode. So in this screen, this is the screen showing magazine front. So this will load the front cover and check the parameter 1. So parameter 1 is equal to 110. This is very important. The parameter 1 is very important. Then coming to the back cover mode, the parameter 1 is 111. That means the module will work in this parameter 111. Okay. So we should understand the difference. For the front cover, the parameter 1 will be 110, and for the back cover, the parameter will be 111. That means 110 is for front cover program. This is related to the front cover, and 111 will be the related to the back cover. Why you should change the parameter? Because as I have already mentioned, the shape is different, right? If you compare the front and back cover, the shape is different and the sensor logic is different, separator position is different, PLC program is different. So PLC should know which workpiece you are going to use. PLC don't know which workpiece you are going to use. So before using this, you should tell to the PLC that, okay, you are going to use front cover or you are going to use back cover. If you enter the parameter 110, then PLC knows that, okay, you are going to use the front cover. If you are entering the parameter number 111, then the PLC knows that, okay, you are going to use the back cover. So these two parameters are very important. So I will write here, very important. So these two parameters are very important. Okay, so let's see that one. Before that, I will check the 6-bar pressure, compressed air. We need 6. So in the HMI screen, we have a mode called setup mode. This is what is called setup mode. Right. So what is the use of this setup mode? So we have automatic mode, right? Okay. So automatic mode means the line will work continuously automatically without any manual intervention, without any human intervention, right? But in setup mode, we can change the parameter, right? So for example, the parameter I have discussed earlier, we can conduct input output test. Then we can check the sensor. We can check the cylinder and commissioning. Everything we can do in this mode called a setup mode. Okay, how we can open the setup mode? Okay, go to the home screen. Okay, once you turn on the machine, open the home screen, and in the left side, we can see different options such as operating mode, overview, user, IO test, process. So from this, select the operating mode. If the application module has not yet started, click on the setup button under operating mode on the home screen button. Okay, click operating mode, and from the operating mode, select the setup mode. If you press this setup mode, what will happen is, so magazine module will go to the basic position. That means home position. Okay. So now I will write here. Now I am in the home, right? Then after that, I have selected the setup mode. Then select the application. Okay. So home, then setup mode, then go to go to setup mode. Now you can see the application, right? Here, so the speciality of this application will be here we can see the sensor details, cylinder, valves. We can see the what is the current status of sensor, cylinder, valve, etc. So the screen layout we can divide into 4 different sections, right? So in the left side menu, we have 3 different menus. See this. One is application, and next one is belt, and the third one is stopper. So application means the module. The application means the application module. We can check the magazine module, sensors, cylinders, valve, etc. Then the second one is called a belt. So belt means this is to test the conveyor belt. Okay, from here we can start or stop the conveyor belt. And the third one will be stopper. Okay, this is to check whether the carrier stopper is working or not. Then we have cylinder and valve status. Okay. Okay, here, this is very important. Here, let's see first. Here, this one lift. So lift means CLMB1. Okay. What is MB1? We already know MB1, right? What is MB1, right? This is valve terminal. I have already explained valve terminal. So MB1 means cylinder lift. So that the duty is to lift the cylinder to the upper position, right? So to move the cylinder to the upper position, so that valve will open and it will goes to the, so this valve will open and the or it will go to the lower position of the cylinder so that the cylinder will go right. CLB1, CLMB1. So near to that we have CLBG1. Okay, what is CLBG1? So CLBG1. So CLBG1 means, okay. So CLMB1 means lift the cylinder to the top position, right? Once the cylinder reaches the top position, then what will happen? BG1 will be activated, right? So cylinder reaches the top position. So cylinder will be in the upper position, BG1 sensor. Okay, then lifting cylinder 83. So lifting cylinder 83 means this is a normal cylinder position value actually. Then next is lower CLMB2. Okay, so lower CLMB2 means, okay, cylinder should move down to the lower position. Okay, once it will reach us here, BG2 sensor will be activated, lower position feedback. Then we have separator, right? Okay, separator, we have two options. One is open, another one is close. So open the separator, it will be MB3, and close the separator, it will be MB4. It will be MB4. Okay, so MB3, MB4, open, close. So it will detect by the sensor BG3 and BG4, right? So this will be showing the complete status of the separator. Okay, so once again, so this will be showing the complete status of the cylinder, right? So MB1, please note MB1, then BG1, BG2, MB2. This is the complete status of the cylinder. And this will be showing the complete status of the separator. MB3, BG3, BG4, and MB4. Right? Next is what is called a clamping. This is what is called a clamping. This is to unlock. Okay, so it is MB5, right? MB5 and clamping 97. Clamping 97 shows the present situation of the lock mechanism. Here, below we can see three sensors, right? Okay, so CLBG5, CLBG7, CLBG8. So CLBG5 0 is equal to magazine empty. That means this will be showing whether the magazine is having workpiece available or not. So green means magazine filled, gray means magazine empty. Okay, so now it is green, right? See, so CLBG5. So BG5. So what is BG5? Where is BG5? Yeah, BG5. So BG5 is showing that okay. So we already filled the workpieces, right? So the magazine is filled. So BG5 is activated, right? If there is no see if there is no workpiece, it will show gray color. Okay, that I will show you. 1 minute. Give me 1 second. Okay, so this section I have discussed, this also I have discussed, then this also I have discussed, and the last one is what is called this one. This is the 3D image of the magazine module. Okay, where you can see the lift cylinder position, separator position, carrier position, everything you can see here. Okay. Then next I'm going to select the application. So during the maintenance time, this application is using. So the main advantage of this HMI screen is that we can see the sensor details, its current status, everything, all the information will be on this human machine interface screen. This is the use of human machine interface screen. Yeah. So in this HMI screen, we can manually operate the actuator. By using this HMI screen, we can manually operate the actuator. So manually operate the actuator means we can manually operate the cylinder, right? We can manually operate the cylinder. We can manually operate the separator, right? And we can manually move the clamp. So the sensor details, uh, whatever sensor details we will be seeing on the screen, that shows the present situation of the sensor. Okay, that will be like a display or a feedback. So in this setup mode, the main objective of this setup mode was we can move the we can move the cylinder up or down. Okay, we can move the cylinder up or down. Okay, using this option lift. Using this number one, we can move this cylinder up or down. Then this number two, this one. Using this, we can either open or close the separator. We can either open or close the separator, right? Then also we can unlock the clamp using this 3. Number 4 is to lower the cylinder up. Lower means number 4, and close the separator using number 5. Okay, let's see this one by one. Okay, so number 1, what is this number 1? So number 1 is this lift MB1. Lift MB1. So lift MB1 means we can move the cylinder up. Okay, if you press this lift button, what will happen? The MB1, the solenoid valve will open. That MB1 valve will open, and the compressed air will go to the bottom side of the cylinder. Because of that, the cylinder will move up. Okay, once the cylinder will reaches the top, it will activate the BG1 sensor. Okay, because once the cylinder reaches the top position, BG1 will be activated. So BG1 will becomes green. Okay, now you can see CL BG1, right? See, in this case here you can see BG1 is showing green color. What is the meaning of this BG1? So what is the meaning of this BG1? BG1 green. So BG1 green means the cylinder is in the top position. The cylinder is in the top position. That is the meaning of this green color of this BG1. Okay. Then coming to the second one, move separator. Okay. So we have MB3. MB3. MB3 means it will open the separator. Okay, if the separator will open, then the BG3 will changes to green. Now the separator is open. BG3 will becomes green. Then coming to the release clamp, CLMB5. This will open the lock of lift cylinder. MB5 will on, clamp will release. CLMB5, sensor feedback. It will shows green color. Then number 4 is move lifting cylinder. MB2. MB2, lift cylinder will go down. So sensor BG2 will be activated. Okay, once the cylinder reaches the down in the bottom position, BG2 will becomes green color. The number 5, MB4, separator will close. Then BG4 will becomes green color. Okay, so here you can see the color is very important. Okay, so the color is very important. Here you can see we have blue color and we have green color, right? So this green is related to the sensor and blue is related to the actuator. operating system. Yeah. So next is the transitions of the application module. This page is actually not a common page actually. This is commonly used during the commissioning time or during the maintenance time only. This is not a normal operator screen. First of all, we should understand what is transition. So this transition means once a process is completed. For example, so once a process is completed, we have to go to the next step, right? So once a process is completed, to go to the next step, we have to give some conditions. Some conditions, right? This is what is called a transition. So PLC will check the transition condition every stage. In the screen where we can see the screen right now, right? In the parameters, right? In the parameters transitions, right? We can edit process step conditions here. This is a table showing. I will explain this table first. Okay, so we have different rows, right? Okay. Step number 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. So every step there is a transition, right? Then start condition. This is the main column. So for example, 100. Then application execute. If tick mark will be there, it will execute that particular step. If it is blank, it will skip. Then we have parameters 1, 2, 3, 4 different parameters. We can give extra informations to each step using these parameters. Now everything is 0, right? Then end condition. Okay. Okay means if the condition is successfully completed, which step we need to go. NOK means if the condition will becomes fail, which step we should go. By clicking this gear button, we can access the transition settings where we can change the condition, we can change the next step, and also we can change the parameter. Once again, this is not a normal screen. So do not operate this screen because this is related to the maintenance or commission. So click this gear. Sorry, setup mode, parameters, transitions. Okay, so next I'm going to discuss the flowchart. So this will shows the complete step-by-step operation on a single diagram, right? Here, we have two types of states. One is S. S means what machine is doing. Okay, for example, lift down or separator open. That is what is called S. Then T means transition. So remember this S and T. So S means state, right? And transition. Transition means before going to the next state, PLC will check a particular condition. This is what is called transition. So transition means waiting. For example, T6 till BG2 on, or T7 till BG4 on. So the complete procedure will be, see, initialization, right? Then ready, then sensor check, then lift down, separator open, wait cover, lift up, separator close, carrier release, ready for the next carrier, right? So the complete procedure will be like this, right? Initialization, ready, sensor check, right? Lift down, right? And separator open. Right? Then wait cover, then lift up, separator close. Carrier release, ready for the next carrier. Okay, let's see the one by one. S1 means initialization. Once we will turn on the machine, this will be happening first. It will check all the start conditions. It will initialize the module. Then after that, T1. So T1 means it will wait for initialization done. So PLC will wait before going to the next step. So T1 means transition. I have already mentioned T1 means transition. Before going to the next step, PLC will wait whether the initialization completed or not. Whether initialization is completed, then it will go to the next step, S2. Prepare start position. Output reset, ready state. Okay. Here, there are two options. One is auto and the second one is reset. So auto means machine will be waiting to get the auto start command. So T2 auto. So PLC is waiting, again transition, right? To check all the conditions correct or not. Auto mode on, start button on, initial position on, yes. Then S3 set busy. Machine will flag set busy, ready off, busy on. Then T3 confirm the busy status to PLC, S4. Then step number is step 4, sensor check. Right here, checking all the sensors. BG5, BG7. So BG5, BG7, BG8. Everything. Then T4. Sensor check, okay. Then it will go to S6. Okay. If the sensor check not okay, that means sensor fail. right? PLC will send an error code T28. Again, go back to where? Again, go back to S2. Then S6, then move down. Move down means lift the cylinder down. Then MB2 on, MB1 off. Then T6 till it will wait. BG2 will be activated. BG2 on. Then go to S7. S7 means open separator. MB4 on, MB3 off. Till wait. T7. BG4 activated. S8. S8 wait position. Okay, machine is waiting. Then T8 means wait position, delay time 500 millisecond. BG8 is checking whether cover is reached or not. Okay, cover reached. Then step number 8, S9, move up. That means cylinder will be going to the upward direction. Then T9 till BG1 activated, it will wait. Then S10, CLS SEP, separator will close. Then T10 till BG3 activated, it will wait. Then S2, machine ready. Okay, this is related to the automatic process. Then coming to the reset button. If you press the reset button, this is not automatic process. Reset process will start. T12, reset trigger. S12, reset lift, right? T122, clamp release. S122, unlock clamp. T13, BG1 is waiting. S13, separator close. T14, again waiting time, waiting for BG3 activation. S14, initial position ready. Then T15, reset complete. Go back to S2.